Hello everybody, this is Mr. Munson. We're at Unit 7, right triangles. So everything we've dealt with in this unit has been dealing with right triangles. We've had a couple of things that we've dealt with. Today we're looking at 7.4. It's basically real world problems and angles of elevation and depression. So what we're going to do is we're going to be looking at word problems, and then we're going to need to make sure we understand when the word problems talk about elevation and depression, where that angle is. But mostly we're going to have to call upon the three previous sections and how we dealt with the triangles to solve the problem. So we're going to have to use our trig, or maybe our special triangles, or just Pythagorean theorem. Let's get started. All right, so we had a vocabulary list that we actually did in 7.1, and so today we're looking at angle of elevation and angle of depression. And so I'm just going to refer back to my video on 7.1. If you don't have those written down, it might be kind of small on your screen. It's plenty large in that video, and I'm just going to let you go back and look at it. Basically, the elevation, the angle of elevation, is the angle formed by the kind of ray that would go straight out from your eyes, straight out, and then the ray that's caused by looking up into the sky. And so in the picture, the person's looking up at an angle and creates an angle of elevation. If somebody was standing on a building, the horizontal line going straight out and the looking down to, let's say, a car causes the angle depression. And so we'll need to understand that today as we go through this. But let's kind of diverge from that for just a second and look at a regular word problem. Okay, so most of the problems that we're going to deal with in this section are going to be word problems. And so in this particular problem, we're not dealing with angle of depression or elevation. We'll do a couple of those. But here it's just simply talking about a ladder that's leaning up against a wall, and they're going to look for some information. So in this particular problem, there's no drawing. So the clue that you would want to do is anytime in a word problem where they haven't drawn a picture for you, you would want to draw a picture. So it says a ladder leaning against a wall makes an angle of 63 degrees with level ground. There's my wall, there's my ladder, and there's my level ground. So now it told me that the ladder and level ground create a 63-degree angle. Reading on, it says the foot of the ladder, so that's the bottom part, the foot of the ladder is 3 meters away from the wall. Okay, so I'll label that. Then it asks, how high up does the ladder go up the wall? Okay, so we have to see this as a right triangle problem, and then is this a Pythagorean theorem problem, a special triangles problem, or a trig problem? And since I don't have two sides of the right triangle, definitely not a Pythagorean theorem problem. Since it's a 63-degree angle in the inside, it's not a special triangles problem, so it's got to be a trig problem. So let's look at creating a trig problem here. Okay, so looking at that angle and that side that they want us to find, and this side down here, we're looking at an opposite and adjacent scenario. So I'm going to write down the trig function that relates opposite and adjacent sides to an angle, and that's tangent, and I'm just going to fill in the information. And then I'm going to solve. Now, I always like to take the right side or the left side when it's this case and draw 1 underneath it to make it a fraction equals fraction. Cross multiply. H times 1 is h. And then you have 3 tangent of 63. Now it's time for my calculator. All right, so after doing that on my calculator, making sure my mode key is in degrees, I find it's about 5.9 feet. Now I'm going to make sure that I put in my units measurement here, and they match whatever the problem is starting out at, okay? Now it does say to the nearest tenth, so that's what I did, and I think we're done with this problem. Let's move on. All right, here's the angle of elevation. And so angle of elevation and angle of depression is the two competing ideas, if you will. Okay, so the angle of depression is formed by a horizontal line and a line kind of going down. That's the angle of depression. In this problem, it's 38 degrees. The angle of elevation is a horizontal line and going up. Okay, so the angle of depression for the guy up in the balloon looking straight out is the horizontal line. He looks down, or she looks down at the person and sees that person creating this angle of depression of 38 degrees. Now, the young woman there has a horizontal line, and she looks up at the balloon and creates an angle of elevation. Notice that both of these are the same angle measurement. And that makes sense because essentially you have two horizontal lines, which should be parallel, and then we're looking at alternate interior angles. And alternate interior angles are congruent when you have parallel lines. So let's make sure we understand how to apply this in word problems. All right, so we have the angle of elevation from John to the kite is 37 degrees. That's already drawn in the picture for us. The length of the string is 54 feet. Approximately how far is the ground distance from John to the kite? Okay, so they're kind of looking for this information. So now we look at, how do we solve this kind of problem? Is this going to be a Pythagorean theorem problem, a special triangles problem, or a trig problem? And since we have to have two sides to find a third side to use Pythagorean theorem, we don't. And since it's not a special triangle because there's a 37 degree there, it has to be a trig problem. So what I'm going to do is try to figure out, in reference to that angle, this is an adjacent side and a hypotenuse. And so I'm going to go ahead and look through my trig functions and see which trig function relates adjacent to hypotenuse. Now, if you do have to look back at your trig functions, that's something you want to memorize. Okay? All right, so hopefully you discovered it's the cosine function. So I'm just going to fill in the information. I'm going to start working the equation. Draw a 1 underneath here to make it a fraction equals a fraction. Cross multiply, and I get x equals 54 cosine of 37. Use my calculator. And it turns out that he's about 43 feet from the kite on ground level. Okay? All right. Let's go ahead and go on to the next problem. Hey, listen, while I have your attention for a second, I want you to know at the end of this video is going to be some try-it problems. But I don't want you to do those as your homework. Okay, so what I want you to do is, if you go to when you get done with this video and you get to where it says try it problems, I want you to disregard every one of those problems. What I would like you to do for your homework this evening is I would like you on a piece of paper to write your name just like you did. You'll write try it at the top and all that stuff, 7.4 try it, and put your name and period over in the top right hand corner. And I would like you to take and write a 7-sentence paragraph or longer of what you like and dislike about the flipped classroom. Okay, and that's all I want you to do. And you just turn that in at the beginning of the period. So it's a 7-sentence or longer paragraph about what you like or dislike, or both, about the flipped classroom. All right, let's continue on. All right, so here we have an airplane is flying towards an airport. The pilot looks down at and sees at an angle and sees the beginning of the runway. Okay, so it says 12 degrees. So we need to figure out, where does that 12 degrees belong? It's not here. Okay, so the pilot is in the front of the airplane, and the angle of depression is formed by, as if the pilot was looking straight out, they look down to the airplane or to the airport, 12 degrees. So this is very important. Notice that the angle of depression typically falls outside the triangle that we've drawn. Okay, so it's going to be important that we not use, say, all of a sudden put 12 here. So if you put 12 there, what we find is that this angle, which has to be 90 degrees, doesn't add up right and everything like that. So you mark that angle 12 just where it's at, and then you start using it to calculate. What I usually do is I know that the angle of depression for the airplane is the same angle down here. So I'll write 12 degrees down here. So if somebody was standing down at the end of the runway, it would take 12 degrees of looking up to see the airplane at the same time. So now I have the 12 degrees in the proper spot of the triangle, and I look at this and I say, okay, so which trig function relates that side with that side? So 4,000 is opposite, and D is adjacent. So let's go ahead and write the trig function that relates opposite with adjacent. And there you go. We're going to go ahead and draw our line, create a 1, cross multiply D times the tangent of 12 equals 4,000. And then I'm going to divide both sides by tangent of 12. And that crosses that out, and I'm left with D equals 4,000 divided by the tangent of 12. Now it's time to type that into our calculator. And there you have it, 18,818 or 818 and 0.5 feet. Okay, so there you are. Okay, so that's how many feet away it is. Now, interesting enough, what I know is that in a mile, there's 5,281 feet. So I don't know how many miles that is. Let's convert that. So I would take the 18,818.5 and I would divide it by 5,281. And that would tell me this is approximately 3.5 miles away. It's actually more like 3.6 miles away. Okay? So to a pilot, that would make more sense to be talking about how far something is. It's about 3.5 miles away, 3.6 miles away, versus it's about 18,818. You know, that just doesn't make a whole lot of sense. All right, let's move on. This next one says a lightkeeper who is at the top of the lighthouse sees a boat out in the water. The boat reports it's 1,517 feet from the lighthouse. The lightkeeper draws the lighthouse. It's 150 feet tall. What is the angle of the depression for the lighthouse keeper to the boat? Down to the nearest whole degree. Okay, so go ahead and draw your picture. Put me on pause and see if you can at least get the picture, and then come back and check your work. Okay, so there's the final drawing there. So now they're asking, what is the angle of depression for the lighthouse keeper? So if I draw out horizontal, the angle of depression is right here. Now I know from previous work that's the same as this angle down here. So I'm going to go ahead and find that angle down there using my trig because I use the inside angles of a triangle to find angles. So once I find that little dot, that red dot angle, then I can just simply say that's the same as the angle of depression in this problem. Okay, so looking at that angle, I have an opposite side and an adjacent side. So I'm going to remember which trig function that goes with. Okay, so that's the tangent function. Now, I don't have an angle name for that, so I'm just going to simply use the letter theta. It's a good unknown when we're dealing with an angle. And so I'm going to actually extend my window here a little bit and draw this tangent of theta. Give myself a little bit more room and maybe make it a little bit bigger for you to see. And so I need to find the angle. So this is when I'm going to use my inverse functions. So we put parentheses around both sides. And then we're going to write the inverse. So in this case, it's tangent inverse. Tangent inverse. Okay, these guys cancel. I'm left with theta equals tangent inverse 150 over 1,517. So now it's time for my calculator. All right, so I got 5.6 something. The direction said round it to the nearest whole number. Now I calculated down that theta is equal to 6 degrees. That's not my answer. See, theta is something I invented in this problem. I didn't ask you to find theta. I asked you to find the angle of depression. So if you told me theta was equal to 6 degrees, I would have to give you less points, okay? So you answer it with the question asked. It said, what's the angle of depression? So you say, the angle of depression is 6 degrees. All right, very good. All right, everybody, here are your try it problems. Good luck. Have a good one. Good having you here. I hope you understood angle of elevation and depression, and have a good one. We'll see you next class.